In this video, we're going to be doing a Kruskal-Wallis test on a sample problem that we've created based on if there is a significant difference in how often different vehicles have to go for maintenance in days. So first step we want to do is we want to make 3 new columns so we can reorganize and sort the data and find the rankings. So we'll do a vehicle column for each type of vehicle, and then we'll do days before maintenance, and the ranks in the third column. Now we just want to fill in the new columns with our data that we've got on the left here. So we'll do FM for Ford Mustang, and we'll just copy the days before maintenance from the first column into the second one, and copy the Ford Mustang down for each of those entries. We'll do the same thing for the McLaren and the Tesla. After we've completed that step, we want to move on to ranking our data. In order to do that, we need to select and sort our 2 columns that have our vehicle and days before maintenance. To do this, we want to find our data selection tab and choose sort. Within sort, we want to sort by days before maintenance in order from largest to smallest. After we've done that, we want to put number 1 as our first rank, and hold Control after you've selected the cell, grab the corner and pull it down to the bottom. Hopefully you have ranks from 1 to 26. The next step is to select your days before maintenance and look for duplicate values. To do this, you go to your Home tab, select Conditional Formatting, highlight Cell Rules, and search for duplicate values. This will highlight all your duplicate values in red. For these values, we want to average the ranks of the equal values of days before maintenance. So for that, we'll make this one 5.5 and that one 5.5. For the same one for below, make them both 23.5. Next, we want to resort our data by vehicle. So go to our Data tab again, find Sort, select Vehicle, and then the order isn't too important, but we'll select A to Z for this one. Then with our newly sorted data, we'll type our vehicle types right here. And we'll input our new rank data under each one of those new columns. Now for ease of future calculations, we'll find the sum of each column's ranks. So we'll call the Ford Mustang rank 1, McLaren rank 2, and the Tesla will be rank 3. So to find the sum, just use your sum function and highlight your target group. And you can do that for the following columns. With this one, we'll just drag the formula across. In the next part of this test, we'll need to find the H sample. In order to find that, we'll have to use this formula for the Kruskal-Wallis test. In this formula, R is the sum of ranks, K is the number of samples, and the degrees of freedom is K minus 1. The distribution is approximated by a chi-squared distribution. You can see here I've added all the necessary portions in order to calculate H sample in Excel. So first, N is the number of observations in our sample. To find this, we can use the count function and highlight our original data. Next, we'll use that 26 to complete our first portion of the equation. Next, we want to use the rank sums that we found from the previous section, square them, and divide them by the total observations in each column. So for the Ford Mustang, you would have 214 squared divided by the number of observations in that column. So what you can do here is use count and just highlight the observations in that column. Press enter. For this next calculation, it's going to be almost identical, except we're going to be using the Maclaurin column and the rank 2. Use the second rank, 97, squared, divided by count, this column. And we'll just repeat the same thing for the third rank. We just take 3 times the number of observations in our sample plus 1. And finally, to calculate our H sample. So in order to do this, we want to take this number multiplied by the sum of all of our ranked calculations minus 3 times n plus 1. Now all that's left to do is find our chi-squared critical value and or p-value. Now to find our critical value, what we want to do is find the chi-squared dot inv dot right tail, and we'll enter our probability, which is our alpha, which is 0.05 as stated at the beginning of the question, and 2 degrees of freedom, because there's 3 groups, and degrees of freedom are the groups minus 1. Next, we'll calculate our p-value using chi-squared dot dist dot rt. And for that, we use our H sample value and our same degrees of freedom. With the Kruskal-Wallis test, the null hypothesis states that the samples come from identical populations or have the same mean or median, with the alternative hypothesis saying at least one of the samples come from a non-identical population. In our case, we reject the null if our H sample is larger than our critical value, and our H sample is much larger than our critical value, so this results in a strong rejection of the null hypothesis.